Okay, good morning, good afternoon, everyone. It has been a long holiday, right? I hope you are enjoying your extended holiday wisely. And in order that this holiday is not wasted, I want to accompany you in the online lessons. And I know that you all feel very sleepy because it's your nap time. But I believe that the topic of our lesson today is enough to keep you awake. Okay, now the topic I bring you today is about the sequence and pattern. And if I have any time left, I will check the previous problems that I have given you. Okay, are you ready? Okay, now let's go on to the definition of a sequence. What is a sequence? And roughly speaking, a number sequence, or shortly a sequence, is a list of numbers arranged in a specific order. Here I have some examples of a sequence. Here I have a sequence. The number 3 standing in the first position, and then the number 5, and then number 7, number 9, and number 11. And here is another sequence. And now let's have a look at something not a sequence. Here I have, this is a set. A set is not a sequence. It had numbers, but the numbers are not arranged in any specific order. And you know that the elements in a set can be rearranged whatever you want. So it has no specific order. That's why it is not a sequence. And one more thing to notice here, in a set, you know that you only write each element exactly once. But here in a sequence here, the numbers in a sequence can be repeated. It is something different from a set. Okay, that's the definition of a sequence. And about sequence, we have several terms. Each term in a sequence is nothing but the number. Each number in a sequence is called a term. And in order to define a sequence, we have to have something called the rule. Like in this sequence, the rule here is each term is 2 units greater than its immediate previous term. It means that the number 5 is 2 units greater than its previous term, in this case, number 3. And the number 7 is 2 units greater than number 5, in this case. And the number 9 is 2 units greater than number 7, and so on. And by following the rule, you can find the next number. Can you? What is the next number after the number 11? Okay, I'm waiting for your comment. Okay, yeah, that's right, it's easy. It's number 13. And the term after that is, of course, number 15, 17, and so on. Now, in the first question, I want you to determine the rule, then find the next 2 terms in each of the following sequences. Can you see the numbers clearly? In the item A, we have 1, 5, 9, 13, and it is asked to find the next 2 terms. Easy. Somebody is saying easy. I guess it's truly easy. Okay. 15 and 17. That's right. The rule here is we add 4 units to each term to get the next term. And 1 plus 4 is 5, 5 plus 4 is 9, and then so on. We have 13 plus 4 is 17, and 17 plus 4 is 21. How about the item B? Yeah, a lot of you have answered the question A very precisely. How about the question B? We have 2, 6, 18. What is the next 2 terms? Yeah, Minh Hiếu has given the answer is 54 and then 162. That's the correct answer. The rule here is that we multiply 3. We multiply 3 to the term to get the next term, and then we have 18 multiplied by 3 is 54, and then 54 times 3 equals 162. That's the correct answer. And now the question C. We have 1, 4, 9, 16. What are the next two terms? You have the question C. A lot of you have given the right answer, which is 25 here and 36 here. The rule is simple. This is actually a sequence of square numbers. We have 1 square, 2 square, 3 square, 4 square, and then of course it is 5 squared 25 and 6 squared 36. How about the item D? We have 1, 3, 6, and 10. Okay, I'm receiving the right answers from you. The next two terms are 15 and then 21. Here the rule here is a little bit harder than the previous ones. Here we have 1 plus 2. 1 plus 2 equals 3. 3 plus 3 equals 6. 6 plus 4 equals 10. And then we will add 5 to the number 10 to get 15. Then we add 6 to the number 15 to get 21. Okay. How about the question E? 120, 720. Okay, you are all right. The answer is, the rule here is to first multiply 2, and then multiply 3, and then multiply 4, and so on. So the next term is 24 multiplied 5 is 120, and then 720. The question number F is quite interesting. I give you about 1 minute to think about it. Okay, I have the right answers from you. Very good. The rule of this sequence is we add 2 consecutive terms, and we have the next term. We have 1 plus 1 equals 2. We have the next term is 2. And then we have 1 plus 2 is 3. The next term is 3. And so on. Now we have 5 plus 8 is 13. Then the next term is 13. And then the next term is 21. Good job, everybody. Okay, so here we have some basic rules to determine some sequence, and you all have done very good. Okay, now I will allow you to examine further to the sequence D here. We have 1, 3, 6, 10, 15, and 21. This is very interesting sequence. It is a name of the triangular numbers. You may wonder why it is called the triangular. And now look at this. Here, first, number 1, I will represent it as 1 dot. And then number 3 is 3 dots. Number 6 is 6 dots. So on. And this sequence gives the patterns of the triangle getting bigger and bigger. And the question is, what is the formula for the nth triangular number? Like I want you to find the 15th triangular number and the the 20th triangular number. Can you find it? Again, I will give you 1 to 2 minutes to think about this question. Okay, I guess some of you have found the answer, right? Now let's check. Now I will use this figure to represent the nth term. The nth term. Of course, because it is the nth term, so it has n rows. Like this. And let's count the number of dots in each row. Here we have in the first row we have 1 dot. In the next we have 2 dots. And the 3 dots. 4, 5, and of course in the last row we have n dots. And the triangular number is exactly the number of dots in the figure. So we add all the dots together. We add 1, 2, 3, 4, 5 to n. So because you are all very familiar with the formula to calculate this sum, right? 1 plus 2 plus 3 plus 4 and then plus n. The answer is very familiar for you. N multiplied by n plus 1 all over divided by 2. Yeah, I am seeing the right comments here. You're very good. Okay. Now let's check the formula to make sure that it is the right formula 1. Here we apply the formula 1 times 2 divided by 2 equals 1. That's correct. 3. Correct as well. Actually, they are all correct. So the formula actually works. Now, I want to try it yourself. What is the 10th term in the sequence 1, 3, 6, 10, 15? Again, I will give you several seconds to compute. It is easy. You just follow the formula that I have given you. Okay, now I believe that you all have your answer. Now let's check it. The answer is that this sequence is a sequence of triangular numbers. So we just apply the formula. We have, because we are now calculating the nth term, so we have n multiplied by 11 divided by 2, and we have 55. Yeah. 55. Yeah, I have received the right answer from you. Okay, very good. Now I have a more difficult problem that apply the triangular numbers. Here we have consider this sequence of figures. How many yellow diamonds are there in the 8th figure? Can you recognize the pattern here of the figures? Từ hence có nghĩa là do đó. hence, do đó, bởi vì vậy cho nên. I'm receiving a lot of answers here. They're all 32, but let's check the answer. First, the diamonds form the figures of triangular numbers. But note that the first figure here is the second triangular number. It is not the first triangular number, because the first triangular number is 1, and here we have the first figure has 3 dots. Here we have 6 dots and then 10 dots. So in the 8th figure, there are actually the 9th triangular number of dots, which is 9 multiplied by 10 equals divided by 2 equals 45. It means that in the 8th figure, we will have 45 diamonds. We have 45 diamonds, but notice that the question is how many yellow diamonds. In each figure, we have exactly 3 white diamonds, and the rest of them are the yellow diamonds. So we need to minus 3. We minus 3 of the white diamonds to get 45 minus 3 equals 42. So the answer is there are 42 yellow diamonds. Okay, because it's 42. Do you agree? A lot of you have made the mistake here is that you think that the first figure is the first triangular number, but in fact, the first figure is the second triangular number. Okay, do you agree now? Before we move to the next part? Okay. Now I would like to examine further the sequence here. It is a very interesting sequence, a famous one. 1, 1, 2, 3, 5, 8, 13, and 21. It is so cool that it has its own name. It has the name of Fibonacci sequence. It is a very famous Fibonacci sequence. The rule of the Fibonacci sequence here is starting from 1 and 1, the sum of 2 consecutive terms is the immediate following term. As you have figured out in the previous problem, we add 1 and 1 to get 2, and add 1 and 2 to get 3, and so on. And now, why is this so important and why is this so popular? Let's have a look at this. I'll have some demonstration here. Now, we have starting from the number 1 here. I will draw a small square, sorry. Here I have a square. The number 1 means that the side length of this square is 1 unit. Next, I have another number 1, so I will add another square of the side length of 1. Next, we have 2, so I will add a square of 2 units. Then 3, 5, 8, and so on. We'll have, if we add more and more square to this pattern, we'll have something look like a triangle, look like a big rectangle. And inside it, we can draw a spiral. if we get really many Fibonacci numbers, we will have a curve very close to the golden spiral. Here is the golden spiral. It is something very popular. Note that we have a curve very close. It is not the exact golden spiral, it is just very close to the golden spiral. Yeah, this shape is very popular because it is the fundamental of a lot of beauty in the world. A lot of architecture, a lot of like design. Take the inspiration from this golden spiral. Like this. Yeah, I will show you a very popular beauty of this golden spiral. Can you see? This is Nautilus shell. Ở trong tiếng Việt thì con ốc này gọi là ốc Anh Vũ. Nó được hình thành theo đúng cái đường xoắn ốc Fibonacci này. Nó rất là đẹp. Yeah, a lot of you have mentioned the Mariel gem, right? We all remember that. The Nautilus shell, ốc Anh Vũ. And there are more than that. Like, I'll give you another example. The beauty of the Fibonacci sequence. Here we have the number of flower petals. Là số những cành hoa. Here we have, starting from 3, the iris, it has 3 petals. About the sakura, it has 5 petals. Actually, there are a lot of flowers in the world that have 3 petals. It is very popular. And the next is 8, the cosmos. Đây là hoa cánh bướm. Cosmos. Quite popular in Vietnam too. And we have scenario. Hoa này gọi là cúc lọ lem. Nó không thực sự phổ biến ở Việt Nam lắm. Được chưa nhỉ? Tức là ở đây các cái trong tự nhiên thì dãy số Fibonacci xuất hiện rất là đẹp và có rất là nhiều những cái vẻ đẹp của tự nhiên tuân theo cái số Fibonacci này. Ví dụ như là những cánh hoa của các số cánh hoa của các loài hoa thì thường là một số nào đó trong cái dãy số Fibonacci này. Okay. And you may notice that the number 4 is not a Fibonacci number. The number 4 is not included in this sequence. And that may be the reason that why it is so rare and it is so difficult to find this kind of four-leaf clover. The answer might lie inside mathematics here. It is hard to find because it had 4 petals and 4 is not a Fibonacci number, and that's why it is so rare. It is unusual. Okay. Actually, there are more to tell you about the golden spiral, the Fibonacci numbers, but it is for another story. Perhaps when we go back to the school. For the time being, I need you to sharpen your skill to solve problems. Let's move to some problems here. Can you see the pattern clearly? The question is, below is a pattern created by repeating a small pattern. Like we make a floor by using tiles, right? This pattern goes on forever, but it is made by repeating a small pattern. We don't know this pattern yet. Draw the pattern from the 122nd dot to the 125th dot. Okay, this question takes some time, so I will give you 1 to 2 minutes to think about it. Oh, sorry, I have 4 options for you because you cannot draw in the chat, right? I'm receiving your answers here. A lot of them are A. Nguyễn Phú Minh Hiếu said that the answer is B. And the rest of you agree with the answer A. Okay, let's check the answer. Now look at this. The first step to solve this problem is to determine what is the small pattern that creates the bigger pattern here. Look at this. We count 1, 2, 3, 4, 5, 6, 7. If we reach to the 7th dot, it comes back to the first dot. It means that each pattern has 6 dots, not 7 dots. This is where a lot of students make mistake. They think that the pattern has 7 dots because when they count 1, 2, 3, 4, 5, 6, 7, when they count to 7, they come to the start. And they think that the pattern has 7 dots. But actually, the pattern had only 6 dots, as you can see in the figure here. And because there are 6 dots on each pattern, we will continue. So after 6 dots, we complete the first pattern. After 12 dots, we complete another pattern, and so on. After 120 dots, we have 60 complete patterns, and hence the 121st dot is actually this dot. And because it is the same as the first dot, and the 122nd dot is this dot. And let's count 122nd, 123, 124, 5. This is the 125th dot. So the correct pattern must be here, B. Well done here. Congratulations for those who get the answer is B. Okay, well, here we'll have another problem. Determine the rule and find the next 2 terms. This sequence here is a little bit harder than the previous ones. So I give you more time for this question. Okay, I'm receiving your answers, and most of them are correct. Here, look at the rule here is if we multiply each term by 2 and then plus 1, we will have the next term. 1 multiplied by 2 plus 1 equals 3, and so on. So here we have 31. We need to multiply 31 by 2 and then plus 1. We have 63 and 127. Okay, good job everybody. It seems that you have no question on this, so we will move to the next question. In the following sequence, sum of 2 consecutive terms is the next term, and we have some blank spaces here. We don't know these numbers yet. So our question is, what is the value of x? Thục Anh có hỏi là consecutive nghĩa là gì? Cái này thầy đã giới thiệu với các con ở trên lớp rồi thì phải. Consecutive có nghĩa là liên tục, liên tiếp. Ví dụ như hai số này là hai số liên tiếp nhau. Cái quy luật của dãy số này nó khá giống với quy luật của dãy số Fibonacci vừa nãy, nhưng mà điểm bắt đầu của nó không giống nhau. Okay, I'm receiving your answers, and most of them are again correct. I'm glad. And now look at the answer here. In order to solve this problem, we are calling this term that immediately after the number 16 is y, and the number after that is 16 plus y, because following the rule, we have 16 plus y must be the next term. So this is the 16 plus y. And following the rule again, we have these two consecutive terms will add up to make the number 68. It means that y plus 16 plus y equals 68. It means that 2y equals 52, and then y equals 26. And now, by working backwards, we'll step by step find the value of x. We have this y is equal to 26, and then this number must be 10, and so on. This number is 6, this number is 4, and finally this number is 6 minus 4 equals 2. Okay, are you all clear? Okay. It's a bit fast. Okay, I'm sorry. I should have been slower. Yeah. Okay. This is the end of the lesson today, and because we have more time, so I will check the problem. I will check the problem that I have given you in the previous the form that I have given you. This is the QR code for the form of this week's problem. So if you can scan it now, and if you cannot scan it, don't worry, because I will send the link after this video ends. Okay guys, because of some technical problems, I cannot connect to the form right now, so I cannot check the problems for the time being. So I think I will have the check for that in another time, maybe when we go back to school, or I will create another form for it. So it is the end of lesson today. Thank you for being with me, and hope to see you soon. I hope that you will spend this holiday wisely. Okay, see you.